Class.
Yes.
That was so weak. Come on. We got to do this again. All right, you ready? Class.
Yes.
That's better. A little bit better. But come on, you got to fake like you're enjoying being here. And that should be every day, right? So, and host G is over there with his phone out again for some reason, but we don't know why. Okay? But for some reason it's there. Simplify each expression. So what this is I'm going to match this to one of my formulas. One of my formulas looks just like this. Let's go back and find my formula sheet. So 1 plus cosine all over 2. One plus cosine A all over 2. So which one's that going to be? The first one. That's going to be cosine of A divided by 2. Yes? Cosine of A divided by 2. So this is going to be the cosine of A divided by 2. But in this case, what is the A value here?
24.
Try again. What is the A value here? It's 12x, isn't it? The A value is 12x. And so what I'm going to do here is I'm going to plug these in right here. So this is 12x. And when I simplify this, 12x divided by 2, can I simplify that or reduce that?
6x.
6x. So it's going to give me just cosine of 6x. That's it. That's it. Look, I circled it.
Wait, so you're just dividing?
Don't just say just.
But that's all you're doing.
That's all I did right here, but it's not all the time just. Just depends on what problem we have. Depends on the problem we have. So, look at B. Look at B.
Why is it like down? Why is it all
Hey, please, up here. Quit zoning out. Right up here. B. What does B match? What formula does B go with?
Tangent?
It's going to be a tangent, right? This is going to be a tangent of, so tangent of some value over 2. Now, in this case, what is that some value that I have? 5 alpha, right? That's what those are, right? So it's 5 alpha. So I take, that's it.
Is the answer?
Yeah, because it doesn't reduce. Does that make sense now? Is that a little bit easier? We're just matching the formula that this goes with and plugging it in backwards. We've been doing it the other way. We start with a tangent of 5 alpha over 2, and then we plug it in this way. But on example 4, we're just taking what I have here, seeing which one it matches, and going with it there. Yes?
Wait, so, you know how it starts with 5 over 5? So 5A over 5A.
Yeah.
So why is it just switch to 5A over 2?
Okay.
Don't you have to make a step and make it
No.
5 to 2?
All right, let's go find the formula. You ready?
Yeah.
Look at the formula. It says 1 minus cosine of 5 alpha over sine 5 alpha. 1 minus cosine, there it is, right here, right?
Yeah.
So it's this one. So 1 minus cosine of alpha. And so whatever this is right here is my A, right? That's my variable. Same thing here. These are both the same, aren't they? So to do this, I'm going to take these, and whatever these are here goes right there. Does that make
Oh,
sense?
this is-
Yeah.
Oh, okay.
So I just took these over here from the right-hand side, and I moved it to the left because I just had to write this out. Tangent of whatever my A value was. In my problem, my A value was 5 alpha, wasn't it?
Yeah.
And then still over 2. And since this one does not reduce or simplify, I just leave it. Just leave it alone. Does that make sense? All right, did we have a part C to this?
No.
Nope. So I'm going to pause right here. I'm going to give you guys some chance to work on a couple of these. So example 4 problems. Let's see if everyone's paying attention. Class?
Yes.
Okay, that one's better. That was a lot better than what we had earlier. So, we just did example 4, now we're going to do some example 5. So we're going to prove that this is going to be an identity. So I'm going to replace a couple of these things, and the side that's more complicated is going to be my left side. And if you notice, these are half angles here. Half angles. This one over here is a single angle. So single angles are just x, y's, and r's, but half angles are not. So I have to use different formulas for these. And since I have this set up like this, it's going to be interesting. Okay, it is going to take some work, so it's just algebra based. So I'm going to replace sine of x over 2, which is going to give me, let's see, actually, I'm going to do that at the end because it's going to be a mess. It's going to say sine of x over 2 plus cosine of x over 2. And since there is a square right there, that means I'm going to have 2 of these. So my second one's going to be over here of sine of x over 2 plus cosine of x over 2. C-O-S, cosine. There we go. So I have 2 of those. So I have a binomial times a binomial. And what is everyone's favorite thing to do?
Fail.
Yep, got to fail this. So we're going to fail this now. So let's go ahead and fail. So right here, multiply the first 2.
Sine.
Yeah, that's going to be sine squared x over 2. And then the next one's going to be all the way across, which is going to give me a positive, right? So it's a plus cosine x over 2 times sine of x over 2. Okay. Now, time for inside. It's going to be the same thing again. So plus cosine of x over 2 and sine of x over 2. And then my last is going to be over here, which is going to be cosine times cosine is plus cosine squared of x over 2. Now, I'm going to take the same thing, but I'm going to rearrange it. I'm going to rearrange it to try and make it a little bit easier to notice or to identify the identities that we're going to use. So, I'm going to rearrange it. Since all these are pluses here, they're all pluses, so I'm going to just move them around. Okay? I'm really not doing any math yet. I'm just moving around. So, I'm going to say sine squared plus cosine squared plus, and now this is a multiplication and this is also multiplication in between these two things right here. So think of it as like a 3 times 5, but instead of saying 3 times 5, I'm going to say 5 times 3. So I'm going to rewrite these so I have sine first, and hopefully that will point something out for you. So it is going to be an identity, but I'm going to rearrange it to match my identity a little bit better. So it's going to be sine of x over 2 cosine of x over 2 plus sine of x over 2 times cosine of x over 2. What's that? That's what? Yes, it is. And it's an identity, isn't it? What's that give me?
R squared. One.
In this case, it's going to be, yeah, it would be r squared, but this is 1, right? Now, it doesn't matter about the angles. I have half angles. It's just whichever angle I have. I could have 30s in both of those, and it would still come out to be 1 when it's all said and done. it's always, since it's sine squared plus cosine squared, whatever my thetas are, it's going to be equal to 1. So all that just turns into 1 right here. Right? So let's pay attention to this next part. Sine x over 2 cosine x over 2 plus sine x over 2 cosine x over 2. What's, go ahead.
Isn't it like break down because
There's 2 of them, right? So can I combine them? They're the same thing, right? So how many of those do I have? I have 2 of them. So it's going to be plus 2 sine x over 2 cosine of x over 2. This is a different identity. That's another identity. Here's a hint. We haven't used this one this week. We didn't use it last week either. It's a double angle, isn't it? This one is a double angle. If you're looking at your reference sheet, it's the double angle one, and it's a double angle for what? Very good. So it's a double angle of sine. Okay? It's a double angle of sine. So I'm going to rewrite this right here over here, because if it's a double angle of sine, so it says sine of 2 theta is equal to 2 sine theta cosine theta. Right? That's my formula. I use thetas instead of alphas or t's or whatever you have in there. Now, for my problem, what is my thetas? X over 2, right? My theta is x over 2, isn't it? So watch this. I'm going to plug this in. So it's 2 sine, but this time it's x over 2, right? Yes? Yes?
Yeah.
Okay. And then cosine of x over 2. Now, what am I going to do with this? Since this now matches what I had on my previous page, right? I'm going this way. I'm going towards this. I'm going towards that. Right, James? Because I know you're not on your phone, right? Because you're up here, right? Okay. Look like you're zoning out. I'm worried about you. Do you need a hug? You all right? You good? Okay, all right. So, we said theta is going to be what in this problem? X over 2. So I'm going to plug it into this one over here now. So now it's going to be sine of 2, and my theta is x over 2, right? Say yes.
Yeah.
Yes. But on the outside, aren't I multiplying by 2? Say yes. The 2, this 2 right here, is multiplying, isn't it? But what is this 2 right here doing? If I'm multiplying and dividing by 2, what can I do with those? Cancel. So that's going to leave me with what? Sine of x. So those will cancel by using my double angle backwards. I'm able to come out to this and I get sine of x. So let's plug that in back over here. So this thing turns into sine of x, and then I had my, and all this together matches this right here, right? So it was a bit of work, right? It was a bit of work. I had to fail the problem, but I used a couple different identities. So that's why I did it in different colors. So you can see the blue one turned into 1 because that was my Pythagorean identity. My purple one right here is my double angle for sine. And then it came out to that. Okay, and I was able to verify it. Is anyone else more questions here?
Can you go back to the other page?
Which one? Where I did the work on it? Okay, yeah. There you go. That one?
Yeah.
Okay. So, other questions? Yes, go ahead.
Okay, so wait, where did the 2 theta come from again? Like the.
This is the
That's
double
just the
angle.
formula.
Yeah, this is the formula. That's the formula for my double angle. So if you look on your reference sheet, that's why I just wrote it out like that.
Oh.
Okay, so it's that formula, and I plugged in what I had, just like we did on example 3,
Yeah.
and I moved it backwards to this.
Oh, okay. Because normally that would be like the rad.
Yeah.
Okay. I get it.
All right. So make sure you all like, share, subscribe. You hit that notification button, and buy stuff from my merch store. And shipping still not yet. You track shipping?
I got them 2 days ago.
Awesome.